Hello students, today we will be learning about the properties of ionic compound. The electrostatic attraction between the oppositely charged ions hold the compound together. Example, magnesium chloride, calcium oxide, magnesium oxide, sodium chloride, etc. Ionic compounds are usually crystalline solid, that is, they are made of ions. They have high melting and boiling points, conduct electricity when in aqueous solution and when melted. They are mostly soluble in water and polar solvents. Their physical properties are they usually exist in a regular, well-defined crystal structure. Ionic compounds conduct electricity in the molten or aqueous state when ions become free and act as charge carriers. In solid forms, ions are strongly held by electrostatic force of attraction and not free to move, hence they do not conduct electricity. You can see a picture here, the arrangement of ions in solid state. The picture below shows the arrangement of ions in aqueous solution. The violet color ions, or you can say the violet colored dots, are the ions move in the negative terminal, and the green color ions moves to the positive terminals when they are in aqueous solution. Ionic compounds such as NaCl does not conduct electricity when solid. Conduct electricity, but when dissolved in water or in molten state, it will conduct electricity because the charged particles are free to move. You can see arrangement here that conducts electricity when the charges are in aqueous solution. Now let us discuss about the melting and boiling points of ionic compounds. In ionic compounds, the strong electrostatic force between ions require a high amount of energy to break. Thus, the melting point and boiling point of an ionic compounds are usually very high. So far as the solubility of ionic compounds is concerned, most of the ionic compounds are soluble in water due to the separation of ions by water. This occurs due to the polar nature of water. For example, sodium chloride is a 3D salt crystal composed of sodium ions and chloride ions bound together through electrostatic force of attraction. When a crystal of sodium chloride comes into contact with water, the partial positively charged ends of water molecule interact with the chloride ions, while the negatively charged end of the water molecules interacts with the sodium ions. These ions dipole interaction between ions and water molecules assist in the breaking up of the strong electrostatic force of attraction within the crystal and ultimately in the solubility of the crystals. So today we had learned about the ionic properties of compounds.